Well, hello everybody. I'm Cédric Bélanger, Product Marketing Manager at Optus, and today I'm very pleased to introduce John Maxfield, Executive Director of the R&D Center and solution dedicated to perceived quality. First, a few words about Optus. Optus is a world-leading company providing virtual prototyping software that are scientifically proven. Optus physics-based software are aimed at simulating the performances of light, simulating the human vision, and finally experiencing your product in its final context. Today, Optus includes also solutions for simulating and experiencing the manufacture and assembly variation. That's what we will discover today. The summary, I will briefly start with the trends, then John Maxfield will develop our PQ solutions, explain the value, and present some customer references. We will finish with a question and answers session. Today, consumers are changing the way they buy product. What is becoming increasingly prevalent in their choice is an emphasis on experience and branding, design and quality. These more perceptive areas focus on product aesthetics. So the perceived quality is the key factor to increase the consumer perceived value of a product. And the higher is the perceived value, the higher is the willing to pay, and more importantly, the higher can be the profit margin for the manufacturers. The two iconic manufacturers that demonstrates the power of perceived quality effect are Apple and Audi. iPhone is not the best feature-based cell phone. It's more expensive than the competition, but the perceived value and the perceived quality of the iPhone are very high. So it beats all the sales record and is very profitable for Apple, as it is the most profitable product in history. That's the Apple effect. In automotive, these sedans are built using Volkswagen platforms, components, and many parts, but carefully hidden behind stylish sheet metal, well-appointed interiors, detailed that justify a significantly higher price tag and greater profits per car. Audi accounted for a little over 14% of Volkswagen Group sales and 60% of its profits. That's the premium luxury effect. So achieving a high level of perceived quality with an excellent fit and finish no longer acts as a positive differentiator for manufacturers. It becomes mandatory. So what is perceived quality and how perceived quality is affected by manufacturer variation? Perceived quality is the impression of quality that customers get when they first encounter a new product. If it looks wrong, it is wrong. It has to be seen to be judged. It's not about numbers, it's about seeing. However, variation during the manufacture and assembly process can significantly affect the perceived quality of the most stunning design, giving customers a bad overall impression of product quality. So the challenge when designing a new product is to evaluate the impact of manufacturer variation on perceived quality. That's the purpose of our solution. Experience the variation early in the design process from a customer perspective and deliver recommendation, modifications, ensuring the manufactured product will reach the perceived quality targets. John Maxfield will explain what it is all about. I will give you the keyboard.
Okay, thank you, Cedric. Good afternoon, everyone, or good morning, depending on where you're from. Okay, as Cedric said, my name is John Maxfield. I'm the Executive Director of Optus Pristine. Our role in the organization is to develop the perceived quality solutions. And as Cedric has just explained, perceived quality is all about visualizing the quality and experiencing the product as the customer will experience it. So if we just move to my first slide. So our solution is all about enabling our customers to visualize the perceived quality of a product using a virtual prototype, using a computer-based simulation. And to do this early in the process, when the design is relatively fluid, when things are changing a lot, and when physical models will need to be changed a lot. So we want to avoid the use of physical models and use the virtual models, the CAD-based models, to look at variation and see this from the customer perspective. And what we mean by perceived quality in this instance, in particular with the products and our customers that use our product, is issues involving the alignment of parts, the gaps between parts, the flushness and so on. Things like the see-through conditions, problems with distortion of components, or the see-through conditions between those distorted components. And we can see some examples here on the animated images on the left-hand side, where the parts don't quite line up, where the interfaces between those parts aren't quite right. And we see this on every single product that's ever produced because of manufacturing variation in the production of the components and the assembly of those components as well. Now our solution, which is basically called Aesthetica, some of you will be familiar with this product. The Aesthetica solution is a desktop-based solution, and it allows you to simulate the effect of variation on the actual CAD-based geometry. So we bring the geometry from the CAD system, we apply variation to that geometry, and you can then experience and see how that geometry will, or how that product will look from the customer's perspective. Now the visualization that we produce inside Aesthetica is good for desktop assessment and analysis, but we also have a complete workflow that takes us from the desktop into the Optus-based VR or immersive VR products as well. So we can truly experience this variation, these problems from the customer perspective and see what the perceived quality will be. So we don't just produce this as a desktop solution, we can go straight to an immersive solution as well. And the output from our tool isn't just about capturing some pictures or capturing an animation. We can also capture all of the information from the study in a report. And these reports can be customized, they can be fully adjusted to match the needs of our customers. And this can be used to document, for example, a full gap and RAD plan. And for those of you familiar with these sort of processes, you'll know that these can sometimes run into tens or hundreds of pages documenting each individual measurement on the vehicle. And because Aesthetica is able to document these, produce these documents automatically, it can save you huge amounts of time in terms of sometimes days, sometimes weeks. So moving forward, if we take a look at the process, we've got a typical process here, and this applies to any product development process. We start with our initial concept and strategy. We work through initial concept development and then into a design freeze, and then working through to the engineering and also volume ramp up to the start of production. So this is a common process that's used throughout industry. And we have initial, if we look at the process, the start of the process, everything up to the point of design freeze, really what we want to achieve is to be able to do everything virtually. We want to have a virtual perceived quality process, because if we build physical models at this stage, often they will need to be changed quite quickly and changed infrequently. And so this can become expensive and very time consuming. So ideally we want to do things virtually at this stage. But what kind of questions do we want to ask of our virtual model? And obviously we have a number of studies that can be performed with our software that allow our customers to understand virtual perceived quality. The first type of study is what we might class as A-class or A-surface feasibility, or target studies for short. And this is asking the question of, what do we want from our model? What do we want to achieve? And that will be, what sort of targets do we want to set on the gaps? What are we trying to achieve with this particular product? And once we've identified what we want to achieve, the next question is, can we achieve it? And so the next type of study that we perform is often using our product is what we might class as a feasibility study. Can we achieve these targets? And can we take engineering information, such as tolerances, information about the way the parts are made, and build that into the model so that we can then start to see, well, can we achieve those targets? Are they realistic? Are they, is this an achievable design? And all of these questions need to be asked and answered at this early stage, but using the virtual perceived quality model. And throughout this process, we don't just want to ask these questions and get some numerical results. We want to see the result, and we want to experience this product as the customer will experience it. So at any stage, we want to be able to deliver an immersive virtual experience. So this is where Aesthetica, this is where our solution fits into the process at that very early stage. And the first question most people ask us is, well, what kind of input do I need? And that obviously depends on the type of study that you're performing. For example, for a target study, we need simply the geometry. In some cases, just surface geometry. But obviously, if we move further into the process and we want to start looking at locator plans and so on, we might want some more detailed CAD geometry. We also might want at the early stages just an initial measurement plan, so where the sections will be, where the measurements will be. But again, we're moving further into the process. We may add locators to this and tolerances and assembly conditions. And the other form of input we will need would be material information. So this is information that tells us what the products look like, what kind of finish they have, and also what kind of physical properties they may have. So if we know what we're going to make a component from, whether it's plastic or metal, we'll have some physical properties or mechanical properties that reflect how that part will behave or deform. And using those inputs within Aesthetica, we can then build our target model or our tolerance model. And once we have that model built in Aesthetica, we can then start to do a desktop review. We can review the targets, we can review the feasibility of those targets, and we can start to look at how the parts will behave and what the product will look like once it's assembled. And of course, from that model, we can then generate our reports, which really capture all of the details about what's going to happen and influence the design and tell us what we need to change in the model. And also we can experience this within other products. So within the Optus portfolio, we have the Thea tool, which allows us to produce a fully immersive model and then see those visualizations and experience them from the customer's perspective. So to give you a bit more information, of an example on this, I've got some movies here which I'll show you over the next couple of slides. In this first one, we're going to take a look at how we prepare the model. And obviously this is within Aesthetica, and we can see the way we use Aesthetica here, that we can use, for example, the first stage is to bring the CAD geometry in without any material. And we can use our material library to quickly paint parts to give it an appearance. And this is a very simple process. But once we've done this, we have a fully detailed model. We can actually see what it's going to look like. And it gives us a reasonable representation of what the parts are going to look like. And based on that material, or based on that basic model, the nominal model, we can then start to create measurements. And in this case, we've got this little purple square, which you can see on the model. And within that, that's a cut section. Within that cut section, we've created two measurements. We've created a gap measurement that measures the distance between, in this case, the hood and the fender. And we're also measuring the flushness between these components as well. So within that section, we've created these two critical measurements. And we can create these sections all over the vehicle. So we can create them, for example, we've got one at the back, we've got one at the front as well. And those also capture the gap and the flush between the same interface, but at different points along that area. And we can then use what we call our force fitting tool within Aesthetica to set these measurements to different values. So here we're going to set these measurements to minimum conditions based on the target and maximum conditions. And you can see it's not just updating the 2D section. We can actually see it updating the model on the screen as well. So we can actually get to see what those different gap conditions or flush conditions are going to look like. And we can set combinations of measurements as well. So in this case, we've set a maximum at the front and a minimum at the rear, and we've created a taper condition. But what we're trying to do here is verify whether the targets that we're setting on the vehicle will deliver the quality that we want. Even before we start looking at feasibility, we want to look at these combinations of targets to make sure that what we're specifying will still deliver the quality that we want. And if not, then we need to adjust those targets. We need to change them in the software and adjust them or reduce them, or in some cases we can get away with a wider target. And once we've done the target analysis, the next stage is to then start looking at feasibility. How can we actually achieve those targets? So if we start adding in, for example, some, in this case we're adding some features that allow us to assemble the fender and the hood and the bumper and the doors. And in this case, we're going to take some of the attachment points, the locating points for the fender, and we're going to copy those features onto the actual fender geometry using an operation which we call paste and constrain in Aesthetica, which very quickly copies the features across to the associated part and creates the constraints for us as well. So it's a very quick and easy sort of cut and paste method for assembling the model from a basic locator scheme. And once we've created those basic constraints and the sequence in which the constraints will be applied, we know how the parts will be assembled, we can also start adding tolerances to the features, both the features on the locators, and also we can start adding tolerances to the A surface parts as well. So form tolerances that allow us to capture exactly how those parts will deform and change. I think we've jumped to a different point in the model. So here we go. So once we've created those tolerances and we've added the assembly system, the final thing is to really identify whether parts will be flexible or not. And we can define in Aesthetica which parts are going to be flexible. And the software will automatically create a mesh, and it will automatically create the it will automatically take account of that mesh and the deformation of the parts during the analysis of the assembly process. We're having a bit of a problem with the movie trying to get it to run. So once we've added all of those components, we can actually then start to run what we call the Monte Carlo analysis, which will virtually build thousands of vehicles and measure them to tell us what's going to happen, or to measure what's going to happen and predict the variation. So once we've run that analysis, we can then go in and look at each of the individual measurements and see, here we can see a histogram which is relative to this little purple measurement at the back of the hood. And what we can see here is this is showing us the range of variation in the gap that we're seeing at that particular point. And we can see that all of the green bars represent vehicles that were built and were within the target, and the red bars represent all of the vehicles that were outside the target. So obviously we're concerned about what's happening outside the target, and we can click on this histogram and we can see exactly what the vehicle looked like for each of these individual measurements that we've taken. So we can look at a maximum and a minimum measurement from the histogram, and we can see on the model exactly what that vehicle will look like when it's at its maximum minimum condition. Because we're rebuilding the entire vehicle for each measurement that we're taking, we can also see what's happening at all of the other measurements as well, and we can look at the correlation between those measurements. So we can see whether we have a correlated movement between each of the measurements, or whether we might have an inverse relationship which causes maybe some taper conditions. Now behind each of these histograms we also have all of the statistics. So we can see, for example, how much of the product was inside the target, how much was outside, and more importantly we can see the key contributors to those measurements as well. So what tolerances, which of the tolerances are having the biggest impact on each of these measurements. And we can click on this list and we can go directly to that within the product tree and see it. We can also look at how the parts are behaving. So when they're flexible, we can bring in a color shader which shows us where all the deformation is on the part. So where it's red, we can see here we've got maximum or a more than 1 millimeter of variation. And when we select samples from our histogram, we can actually see what's happening to the parts. So we can see all the different areas where the deformation is taking place. And so we can get a really good insight into not just which locators are having the biggest impact, but also on the behavior of the component as well when it's assembled. And all of this information is available to us within this desktop tool. So you can see that the visualization is good. It allows us to see the variation and make some judgments. But obviously, if we want to then step this up to the next level, we can pass this model as it is right now from Aesthetica directly into one of our virtual reality products. So on the next slide, we can see taking that model from Aesthetica, we can drop that directly into Thea. And within Thea, obviously, we can see we've got a kind of stepped up a level in terms of the visual quality and the visual realism, but we still have all of that variation data behind the model. So we can look at each of the individual samples, and we can look at not just the movement, but the deformation of the components as well. So we can start to experience this as the customer will see it in a lot more realistic, way. And once we're in Thea, we can also then take the next stage, which is to move forward into more of an immersive experience. And this is a movie that's captured from a project we worked on with Bentley called Strive. And this allows us, you can see here, that we're actually able to immerse ourselves within the vehicle, and we can actually start to interact with the object as the customer will. And we can see not just how the product will look, but we can actually see the variations as well, not just interact with it. We can see how the variations will affect individual interfaces. So in this example, for example, we're combining the output from SPIAS, our light simulation, with the Aesthetica variation, so we can actually see what the interreflections and the highlights will look like when we have variation within the product. And this was a very useful study that was undertaken with one of our customers, so with Bentley, to look at this variation between, for example, the door to IP gap from the driver's position and also from the customer's, passenger's position, which is a kind of compromised situation because it never looks right from both positions. It will always be a compromise between the two. So this gives you an example of, I hope, how we can prepare the model. Now, the animations I've shown you there are all captured directly from the tools. So what you're seeing there is work that's done effectively in real time, in preparing the model, in preparing the target study, undertaking the variation, looking at different types of target variation, and then looking at the feasibility against those targets, and then working through that workflow into the immersive process. But the key differentiators really with our product, I'd like to go through now. Number one is really the ease of use. Number one thing that our customers tell us is that our product is very simple to use, and it doesn't have to be used by specialist GD&T experts or say tolerancing experts. The product is quite simple to use, and often, particularly in the early stages of the process, it can be used by engineers or designers who have no knowledge of tolerancing. And we can train them on exactly how much information they need about tolerancing to use our product. But they don't have to be necessarily hardcore DVA engineers to use the product. We also improve productivity through use of our tool, in particular through the use of the report generator, which is, as I said before, it's fully customizable. But the benefit of that tool is that it can produce reports that may have tens or hundreds of pages within minutes. It can produce those reports very quickly and easily and save you a huge amount of time. Now, because the output is not just in form of numbers, it's not just in the form of histograms and so on, the output is always related back to the 3D model. This makes it easy for everyone to understand the nature of the problems, and therefore allows for cross-disciplinary collaboration and allows perceived quality to be understood by everyone, and the impact of variation on perceived quality to be understood by everyone on the team, and not just people who understand the analysis data. We can also, because of the workflow, because of the fact that we can work very quickly transition very quickly from a desktop into the immersive virtual reality, it allows our users to really start to appreciate perceived quality and experience it from the customer perspective, not just on a desktop screen, but in an immersive world where they can truly start to interact with the product. We can also support, because the software supports flexibility built in, all of the meshing and flexibility calculations are built into the product. So is the report generator and so on. Everything you need to do this kind of work is built into the product. You're not having to go and shop around for additional tools or modules to do various things. It's built in, it's a complete package that allows you to solve perceived quality problems. We've also built in new capability, in this case the ability to add split lines. So if you're working at a very early stage of the process with just surfaces that haven't been split up, you can actually start to implement some of the splits on the surfaces, the radiuses included, and also some of the flanges. So you can actually start to work with variation models very, very early in the process. And because we have this VR connection, we're not just connecting to our own Optus VR products, we can also connect to other VR products as well. And this obviously gives, we can fit into the workflow within pretty much any process, not just by processes that use our own VR tools. The interesting thing as well with Aesthetica is that a lot of people seem to think this is a new product. It's not a new product. It's been on the market for over 10 years, and it's already used by a number of clients, and it's been used by a number of clients for a number of years. It's trusted by them and it's used by them. And in particular, we have reference cases where our product has been used to improve the perceived quality, to save time and money, and we'll talk about those on the next couple of slides. But in this particular instance, our software, it's worth bearing in mind that the original process that I showed you at the beginning of the slides, because typically our software is used by advanced engineering or by a feasibility study engineers who will be working alongside concept departments or design departments. So the work is done very early at an early stage. And this is typically the only variation tool that is used at this type of level of at this early stage of the process. And we can see here some quotes from some of our customers that obviously help to identify where the real benefits of the process really are. So if I take, for example, our first customer reference, in this case Nissan, their challenge really was to try and accelerate the process and improve quality, but without increasing cost or resource or headcount effectively. It was a real challenge because they were trying to reduce the process time, the time it takes to produce a product, significantly. And through the deployment of Aesthetica, they were able to improve perceived quality and also build quality, but also encourage true collaboration between the teams. So the PQ teams in design, PQ in engineering, and also to identify some major cost savings within the program. For example, on just one of the programs they worked on, they saved over €500,000. The second case reference which we have here is Bentley. Bentley have been using the product for a number of years. Obviously, it's shifted several times within the organization itself, but through the project we worked on and research project we've worked on called Strive, we were able to help them to understand how to use all of the Optus tools in an integrated way, not just Aesthetica, but also all of our VR products and our manufacturing simulation products. But the challenge here is different to Nissan because Bentley is in a very different market. They're obviously trying to deliver a very premium quality product within an increasingly competitive market at that level, but also trying to control cost, as with all organizations. And we were able to prove through the Strive project that using the Optus tools, they could improve cross-functional collaboration, promote this idea of right first time. So instead of building several physical models, they could reduce the number of physical models by building things virtually and iterating the virtual builds before committing to anything physical, but also reducing the development costs and number of physical prototypes and improving perceived quality throughout the process. Now, both of these case studies and customers, we have a handout which is attached to, I think if you go to your go to webinar tab, you'll see that there are two handouts there, which are actually articles that were written by these customers on the use of Aesthetica and the benefits that they saw through the use of those tools. You're free to download those and look at them at your leisure. So you might also ask the question of why specifically work with Optus in this particular field. Well, in essence, Optus has a unique capability in the fact that we have technology that spans not just light, accurate, physical-based light simulation, but we also have the variation simulation with Aesthetica. We also now have sound simulation through new technology that we've acquired. Through the Strive project, we also started to introduce haptic feedback and also force feedback, which gives you the ability to start to feel and touch objects in the virtual world as well. And we are in a fairly unique position in that we can combine all of these, and we are working very hard now to combine all of these technologies to create the ultimate PQ experience in the virtual world that engages all of the human senses, and not just being able to look at things, but being able to actually truly experience a product, to be able to touch it, to feel it, and to really experience that product and hear it. What about in the future? Potentially smell, maybe sound. We can introduce all sorts of things into the system, but ultimately our goal, one of our visions within Optus, is to deliver this ultimate virtual PQ experience. And so working with Optus, you're actually going to be working at the state-of-the-art, the latest level of technology at all times, and we will deliver this through to you as our customers as early as we can, and probably earlier than pretty much any other company on the market today. So I'll thank you for your time and listening to me. I'll hand back to Cedric now, and hopefully if you have any questions, we'll be happy to answer them.
Thank you, John, for this very nice presentation and the very impressive technology you are working on. Yes, just a reminder, you will find the two case studies, Nissan and Bentley, in the handout. You, of course, you can ask your questions using the question panel. So we will stay connected, remain connected with John. So if you have any question, please, it's time.
Okay. Okay, there's one question in from Nick Boyd. Okay, this is regarding materials. So you're asking for materials you're applying, are they the same as Spios materials? Could Spios and Aesthetica work off the same CAD file with all of the appropriate materials and light sources applied as they are updated? So and eliminate double work. Okay, so and also what is the level of integration with VR experience. So in terms of using SPIOS materials, we have a very similar product to Aesthetica called SVM, which is the SPIOS variation module. And this is actually taken the Aesthetica variation technology and integrated it with the SPIOS technology. So yes, we can. It's a slightly different module. It's part of SPIOS tool, but it means you can build a SPIOS model within CATIA or within NX with SPIOS materials, and then we can apply the variation to that, so you can actually have it all in one model. In terms of integration with VR experience, we are working on that at the moment, so that the level of integration we have at the moment with Thea and with HIM is a file transfer. So you go from SVM or from Aesthetica into VRX using or into Thea and HIM using a separate file. But we are working to have that more directly integrated, so that you can kick off Thea or HIM from directly from the SVM tool. The follow-up question. Okay. The next question, there's a follow-up question, which is that there's already existing GD&T tools, and do we have any hard metrics regarding time and cost savings? Charts and graphs are useful. Yes, we do. We've got return on investment slides, which we can share with you, which come from several of our customers, which show exact savings that have been made using the tool. It does work alongside existing variation analysis products, but provides that visual output. So we can take the results of studies from VSA or 3DCS, and you are able to then augment that with the visualization from Aesthetica. If you have a look at the handouts that we've provided, you can also see some numbers in there from the customers. I don't think they're quite so explicit, but we do have other return on investment cases we can share with you if you want to. We can follow up with that, definitely. Let's see. I can't see any other questions at the moment. Okay, so I think if anyone has any other questions, I think we can obviously.
Yeah, I think
if you want to email us and ask us any other further questions, then please do. Happy to answer them and follow up.
Yeah, thank you, John. I think yeah, if you have any question, we will send you the link to the recorded webinar. And as you can see, we have a global presence for local understanding. So I invite you to contact your local subsidiary and ask for an evaluation. You will see the contact on the Optus world.com on the website.